Hello and welcome to the very first edition of Baxi HeatWave. Baxi HeatWave is a series of programs where we'll be getting guests in and talking about the most relevant things affecting the heating industry. So without further ado, let's introduce our guests.
Hi, I'm Rob Pearson, one of the Baxi training officers. I'm also responsible for creating content for our online learning platform.
Hello, I'm Will Smith-Young, Technical Team Manager for the UK and managing both the commercial and domestic helplines.
Hi, I'm Andy Gregory and I'm a senior trainer here at Baxi.
We offer a range of courses now. Can start off with the very basics of how heat pumps work right through to being accredited. And, for those people that are kind of sitting on the fence with it, now is a good time because, some of these courses are kind of government funded as well.
And government funding is continuing actually, and it's really important that we know that government funding is on heat pump courses at the moment, low temperature design courses at the moment. It's also on obviously the bus grant for buying a heat pump for the end user, for the customer. But
the thing is that will, the funding for the courses, that will get pulled at some point, won't it? I imagine. I don't know. But, if you don't get on it now, you could end up paying, upwards of £900 for the same course where you're paying.
It's definitely an opportunity. It's definitely an opportunity to, that you can take hold of now and develop yourself and your business at very little cost, effectively. And there are opportunities out there, and we've seen that some of the companies that we work with, have moved away from their traditional boiler base effectively and moved much more into heat pumps. Some have set up different sections to their business to concentrate on heat pumps, but what those companies are doing, they're getting in there early, aren't they? And they're making the most of the opportunities that are there now. Yeah. And at the very least, I would say, you need to get yourself ready for when the opportunities are.
And like I said, we've seen people from installers to system designers attending these courses, so there's a lot more opportunity out there to kind of expand your business if you want to.
Yeah, and that's what this is about, really, isn't it? It's about having more opportunities for you, for your customers, more solutions that you can offer your customers, and different ways of developing your business. Yeah. So we talked a little bit about how we control systems using stuff that's been around for decades, through load compensation, weather compensation. Let's talk about it on a more individual level, so boilers, heat pumps, and that. And there's a lot of conversation around delta T's and the differences between different pieces of equipment. So Andy, do you want to pick up on that?
Well, yeah. Going back to basic system design when it first started in the industry, that was always 11 degrees delta T temperature.
Right.
Difference.
Can I just ask you what delta T is?
Yeah, it's a temperature difference. Okay, so we're talking about the difference between flow and return temperatures.
Coming out of in this case, a boiler.
In case of your boiler, yeah. And traditionally that was 11 degrees, of which a lot of people think it's 10 degrees. So 11 degrees was what we were designing to at that point. Today, we're designing to a delta T, a temperature difference of 20 degrees between our flow and return.
And this again is on boilers?
It's on boilers, yeah. So traditionally.
So why? What's the difference?
It's really aiming towards getting a lower return temperature, which is keeping that boiler in that condensing mode longer and gaining that efficiency.
How does that work? So why have I got a boiler that's okay at 11 degree differential, and now it's a condensing boiler?
The thing is, if you had an old standard efficiency boiler designed at a 20 degree delta T, then it's going to be condensing on the heat exchanger, isn't it?
Which I don't want.
He's going to fall apart.
Yes.
And disappear quite quickly.
So that's why my delta T on my old appliances is 11 degrees, starting at say 80 degrees, and then my return temperature, if I do my maths right.
69.
Sorry.
69.
Yes, 69.
69.
Sorry, yeah. So the return temperature is 69.
See, that's why people use 10 degrees, because the maths is much easier.
You're absolutely right. It's much simpler.
So should we say 10?
But 69 degrees, I'm not condensing. Okay. And what's the condensing point for a natural gas boiler? Do we know?
We're talking 55 return, 45.
Yeah, want it below 55.
Lower the better, isn't it? Really?
Yeah. So originally when condensing boilers came out, there was two trains of thought. The initial thought was the temperature change to, what did you say? It was 20 degrees.
20 degree difference, yeah.
So, well, what's the difference? Why am I going from 10 or 11? It is 11, everyone. To 20 degrees.
Because I need that flow temperature or the return temperature to come back cooler, so the boiler can carry on condensing.
Because it is condensing.
Yeah.
Now I do want it to condense.
Now I want it to happen.
Yeah, and because I can gain all that extra energy for that latent heat. So I've gone from 11 degrees to 20 degrees. I'm getting a much better return temperature. Of course, that would have meant larger radiators for higher output, wouldn't it? Which is why some people lowered the flow temperature rather than get the temperature difference. And then what's next for Delta T's?
Well, to where we are now. I mean, Rob's been talking about heat pumps and Delta T on the pipe work for a heat pump. We're looking at a 5 degree difference. You know.
Why? Why do I need 5 degrees now? Whereas it was 20 degrees down to 5 degrees.
Well, it's going to be down to your heat pump operating correctly, isn't it? I mean, you know, we can talk about gas boilers. They obviously need a good working pressure of gas, don't they? A heat pump, it really needs a good flow of water. So for it to operate correctly, it's got to have a sufficient flow of water, which is probably going to mean that, you know, pipes are going to have to be upsized.
But why? Why do I need a sufficient flow of water? Because on my gas boiler, I know this is not efficient or correct, but I can blast a load of heat in like a kettle and then pump that heat out. And I can get the return temperature comes back, whatever temperature, I can blast a load of heat in there and then I can pump that out. Why can't I do that with a heat pump?
Why can't you just blast the flow temperature up?
Yeah.
Running costs, isn't it?
But why? Can you explain to me why? How does it work?
So, I mean, we'd probably recommend a flow temperature coming off a heat pump that uses, your traditional panel radiators. Let's say 45 degrees. So if you're using a 5 degree Delta T on that, your return temperature wants to be about 40 degrees, doesn't it? So obviously you've got to think about how quickly you're shifting that water. So you're increasing it massively, aren't you? So you're sending it out and you're getting it back as quick as possible, so you haven't got that wide Delta T gap.
So if you had that 20 degree difference, then the return will be so much lower, which makes the unit work so much harder to get back up.
That's the key bit there, isn't it? The unit will work so much harder. It's about the compressor, isn't it?
Yeah.
So if and I love an analogy, so I'm going to use one. And so if I liken my compressor to a roundabout in a kid's playground, right? If I'm running it flat out, I'm putting loads of energy in to get it spinning, right? And that's what I don't want to do, which is why I want your much lower Delta T, because then I can run my compressor, my roundabout, at a much lower speed. I'm putting less energy in. So I want to raise the temperature difference a little bit. I want a 5 degree Delta T, so I don't have to put as much energy into my compressor to raise it to my flow temperature. Yeah. That's pretty much what we're saying, isn't it? Mm-hmm. Yeah. And what I don't want to do either is start and stop my compressor, because if I oversize it, then I'm not going to get rid of the heat.
Yeah, you've got too much heat available there.
And likewise, if you undersize it, then going back to your roundabout is having to work so much hard to spin at that degree.
Which explains really why getting design right on heat pumps is crucial. Whereas boilers are very forgiving, gas boilers are very forgiving, heat pumps are not as forgiving. Yeah. And I don't want to put any more energy into that compressor than I need. And the two ways of putting too much energy to compressor is oversize it, so it's stop, start all the time. That uses a lot of energy. Undersize it, so my heat pump is running flat out, my compressor is running flat out, consuming lots of energy, and my coefficient will go down. How much energy I'm getting out for how much it goes down. Is that fair?
Sounds right to me. Yeah.
So basically we're saying, get your design right.
Yeah, 100%. If you want to learn more about roundabouts.
Which is what we've always been saying. You know, that 11 degree difference, it's all about design and achieving that 20 degree difference, design and achieve that. And now we're talking about 5, it's pipe work, it's pump capacities, it's heat pump outputs, getting everything right.
So a lot of people that come into the training centres, they generally say that, you know, heat pumps are fine for new builds, and maybe that's down to obviously minimal heat losses. But, you know, that conversation we've had about system Delta T's there, an air source heat pump system working on a 5 degree delta T is actually closer to an older system working on 10, 11. So, you know, a lot of people are saying, oh, I'm going to have to rip everything out and start again. But chances are you might not need to. I mean, even radiators as well. If you think of a radiator that was sized or fitted in the 80s, if someone's done a heat loss calculation for the lounge and decided that the radiator needs to be so big, you've got to imagine that customer may have had their windows improved over the last 40 years. They probably improved the insulation of the building. So that radiator that's been there for 40 odd years is probably oversized for that heating system.
And adding the fact that people were using a Mears calculator in the 80s, which said in the instructions you oversize by, this oversizes by 10%.
Yeah.
It told you. And then the vast majority of people also stuck a little bit more on top, just in case. And we were oversizing equipment in the 80s, definitely.
I guess when it comes to radiator sizes as well, you know, let's say you've done a heat loss calculation for a room and it's come out at, I don't know, 990 watts or something. The chances of you finding a radiator that will deliver 990 watts at that different system delta T is pretty slim. You're always going to oversize it.
You're never going to go to 900, are you?
No, exactly. Yeah. So you'd always oversize it a little bit. So if you think you've got, I don't know, 6 or 7 rooms in a house and all those radiators are slightly oversized, there's almost a call there for, you know, when you get into the depths of setting your weather curve and stuff, you'll look across, and I think you use the example of when it's -3 outside, you want a 45 degree flow temperature. So let's say for argument's sake that that's curve 2. You might want to drop that curve down slightly because your radiators are going to be slightly oversized, if anything else.
Yeah, and that it comes back to that engineering judgment, doesn't it? So all of this comes back to upskill yourself.
Yeah.
And it's more important now to upskill yourself so you can talk confidently to your customers to prevent those callbacks or the calls into Will's team, so asking about how do I run this system? Why my radiator's not hot? You know, and we've all heard it. We've all heard heat pumps don't work in anything but a new build. They're noisy. You know, they'll never work in a UK climate. You know, we've all heard all of these things. Yeah. But the reality is, if you design a heating system, regardless of what it is, correctly, and install it correctly, and give the customer the correct information, the thing will heat the house.
Yeah, just interrupting there, Ian. Giving your customer the correct information, the handover's changed as well. You know, you could normally say to a customer, there's your heating thermostat, hot water thermostat, a reset button, pressure gauge and top-up method. But you know, that's handing over and your controls are very simple without load compensation and weather compensation. Now the handover's a lot more lengthier period so that you can get your customer to grasp these methods of energy saving. And then once they grasp that information, it's going to work and operate, isn't it?
Yeah. I think, like you said, handover, I think it's almost the start of the process, isn't it? When you take on that customer, you've got to explain to them that this system's going to work in a slightly different way. It's still going to heat your home fully.
Yeah.
Just maybe not in the same way you used to.
Stop touching your radiators.
And Rob mentioned earlier, asking that key question when you was a Baxi customer support engineer, are you warm enough?
Yeah.
Yes was the answer to that.
Yeah.
You know, but they feel like the system's not performing as they would think.
Yeah. I mean, you know, a customer's never going to phone you and say, "Oh, I think I need you to come out and adjust the weather curve for me." But if you're doing a service on an air source heat pump, and one of the questions you ask the customer is, "How's it been?" If they turn around and say, "Do you know what? It's actually warmer than I thought. I've seen a load of things on Facebook and on the news about how bad heat pumps perform." If they're telling you that it's warmer than they thought it would be, they've just told you that you can crank that weather curve down.
Yeah, ask that question before you start working on it.
Yeah. But again, you know, going back to what I said earlier, if you can drop that flow temperature by 1 degree on a heat pump, that customer's going to be saving money on their energy bills, isn't they?
Yeah. Yeah, and it is about customer expectations at the end of the day, isn't it? It's about you must deliver what the customer needs, you know, and it's because if you don't, then you're just asking for those callbacks again.
I think with, you know, customers that are asking for air source heat pumps, they've already done some research. Yeah. They might have conversations with you about, you know, what's the seasonal coefficient of performance of that unit. So, you know, coming on courses like the Baxi Air Source Product Day, you know, that'll get you familiar with some terminology about what, you know, customers have researched. If you
That's a
like.
really good point. It's almost full circle back to where we started the conversation about people not knowing anything, not uncertain about that journey.
Yeah.
If you load yourself up with knowledge now, when you do get an inquiry, because they will come, heat pumps are becoming more and more popular every year. When you do get an inquiry, you'll be in a much better position to answer that inquiry rather than just sort of fob it off or
You're not on
pass
the
it
back
to somebody
foot. So
else.
if a customer says, "What do you think of heat pumps?" and you're not going to go buy the rubbish. But what are you basing that on? Someone posted something on Facebook about it. It's like not everything on Facebook is true.
No.
Apparently. Yeah. That's something.
So we spoke a little bit about boilers and the difference between boilers and heat pumps and differences between condensing and non-condensing boilers. But there are differences within the heat pumps as well. One of them being the refrigerant. So we want to talk a bit about refrigerants, Rob.
Yeah. So one thing that regularly comes up on a training day is a lot of installers say that they don't want to get involved in air source heat pump installation or service and maintenance because they're not F-gas registered. Now, to install or service a monoblock unit, you don't need to have your F-gas ticket. Now, there's a couple of types of different heat pumps out there. I'm going to concentrate on two, one being the monoblock. So the monoblock is an outdoor unit. I don't know if you can see that just behind me there. That's not supposed to be indoors. But all of that refrigerant is hermetically sealed, meaning that the manufacturers kind of pressurise that refrigerant. You don't have to do anything with that. You are almost just connecting a flow and return pipe to the unit and then going straight into the property. A split unit, on the other hand, you would need to have an F-gas qualification to install or service it or handle the refrigerant because you will have an outdoor unit, which is like a smaller version of a monoblock, and then you'll have an indoor unit as well, and they will be connected with refrigerant pipe work.
Okay, so split, I'd need F-gas to install it, and monoblock, I wouldn't need F-gas to install it. Okay, and there's different types of refrigerants that are commonly used as well?
I mean, over the years, I won't go through the list of them. I'll talk about two for now. You've got the R290 refrigerant, which is also propane, commonly used in most modern heat pumps, so like the Baxi HP60. And we've also got the HP40 heat pump, which has the R32 refrigerant in. The R290's got a lower global warming potential than the other.
Okay, but what would make me choose? If I'm designing a system, why would I choose R32 for one application and then 290 for another?
It depends on the customer's needs, really. If that customer needs a high temperature heating system, you'd probably go for the HP60 with the R290 refrigerant in, as it is capable of delivering 75 degree flow temperature. But again, going back to the running costs, it could cost quite a lot.
It's got a wider operating envelope, isn't it? It can operate across a wider range. It makes it a bit more suitable for more complex installations or higher heat loss houses.
Yeah.
But we still try and keep that temperature as low as possible for design purposes.
You always want to design at the lowest flow temperature possible without compromising on comfort or efficiency.
Yeah.
Rob, just to interrupt there. So it could also depend on siting, couldn't it?
Yes.
So you can't put an R290 unit in as many places as an R32 unit, purely because of the type of refrigerant.
Yeah, and I'm sure, Will, you probably get these questions.
About the siting.
With an R32 or the Baxi HP40 heat pump, siting requirements, you can pretty much go where you like if you want. When you look at the HP60, it has the R290 refrigerant. Because that refrigerant is heavier than air, if you want, then it can't be sited too close to things like a drain or a window. And I'm sure you have people calling up about that.
Yes, it's just another factor they've got to consider, along with everything else to do with this heat pump install.
Yeah.
Where's the outdoor unit going to go, and what clearances do I require?
I always tend to say to installers as well, almost forget everything you know about boiler installations, because you could almost get a phone call off a customer, and let's say Ian's the installer, I'm the customer. I could say, hi Ian, I need a new boiler. It's completely broke down. Ian could say to me, what boiler have you got currently? And I'll say, I've got a 24 kilowatt combo. And Ian could almost quote me over the phone, come the next day and fit it for me. But with an air source heat pump, it's all about the planning. So it's about preparation of the site, isn't it? You can't just turn up on the day and chuck the heat pump outside the house and hope that it works. There's a lot more thought there.
That's a really interesting point about that planning part, because typically a boiler install is reactive, isn't it?
Yeah.
You know, so we're moving into a more of a proactive world, aren't we? Where we say, actually, I'm going to plan this installation. You know, because a heat pump in today's world is not generally a distress purchase. You know, if your heating's gone wrong, you're probably not going to wait a number of weeks to get the survey done, to get all the plans done, to get, if you're going for the bus grant, to get that paperwork through. You're probably not going to do that. You're probably going for another boiler. So if you are thinking, if a customer's out there thinking, you know what, I think my next heating system should be a heat pump. That's what I want to aim for. Start planning it now rather than later. Get yourself ready. And installers, you know, talk to your customers when they're out servicing gas boilers. If the customer is inquiring about a heat pump, now's the time to start talking about it and maybe planning it, because then when it does come to time to change the boiler, you've already done that legwork.
Yeah, instead of being hit with like a big quote, for instance, you know, because you're upsizing all the radiators in the property and all the pipe work, you can do it bit by bit, can't you? So, you know, when you're servicing a gas boiler and, I don't know, that boiler's 8 or 9 years old, have the conversation with the customer, just say, you know, are you thinking about having a heat pump in the future? And if they say, you know, yeah, I've been thinking about it, you can obviously teach them that trick with the flow temperature on a condensing combi boiler, lower it as low as possible, only when it's your worst case design temperature, like your -3s or -2s, and take it from there. And, you know, if that customer phones and says, oh, my radiator in the bedroom's leaking, you know, that might be time to upgrade that radiator and upsize it.
That brings me nicely onto legislation, because that's one of the drivers of legislation. So Andy, you've when you train, you talk about Boiler Plus, you talk about the changes to Part L, and one of those changes was about heating system design. Was it even for gas boilers and the temperature? Do you want to talk a little bit around that?
Well, yeah, Part L, June 2022, brought in the requirement that if you're installing a full central heating system, that full central heating system be designed to low temperature.
And what temperature should it be designed to?
We're looking at 55 degrees circulating flow temperature.
So that's absolutely driving people to get heat pump ready, aren't they? You know, so it's about
future proofing.
Yeah, future proofing your property. So if it comes a time where you have a heat pump, that leap into that heat pump isn't as bad, because you've already got radiators that can cope with that sort of temperature, that lower temperature.
Yeah, and another thing we talk to installers about, if they're going to exchange an unvented hot water cylinder, then if that system does require a replacement product, then that could be an unvented air source heat pump cylinder, future-proofing it so that if that customer does go for an air source heat pump installation, they've already got a cylinder that's ready for it.
What else do I need to know? What else is an installer? What else would I need to do? I need to be qualified in. As you said, I don't need F-gas qualification if I wanted to move into that world, if I'm installing monoblocks. What about the boiler grant, the boiler upgrade scheme? Do I need any qualifications for that?
So there's a lot of talk about MCS. We do get a lot of installers saying, it seems like a bit of a minefield going through the MCS process. We can offer that at Baxi, so you can work under the MCS umbrella. You can have a look at the website to find out a bit more on that. That will allow your customers to then apply for the boiler upgrade scheme grant, which is currently £7,500 in England and Wales. I think if it's oil or LPG, up to £9,000 grant. So it's a good time to, if your customer's thinking about a heat pump, probably a good time to start.
Yeah, the grants are available. So when you talk about an umbrella scheme, that's a scheme that's administered by, in this case, Baxi, that you as an installer can just work under, and that will do all the paperwork side for you, won't it?
Yeah, and I always kind of chat to installers that have got a good background in fitting boilers. I mean, registering a gas boiler, it's like a one-page document, isn't it? The benchmark, if you like. When you're looking at air source heat pumps, the MCS kind of paperwork side could be up to 83 pages, and that will cover everything from system design to noise calculations and all the fun stuff in between, and we can obviously do that side for you.
It can be time consuming, can't it?
Yeah. I mean, you imagine a heat pump install might take you, let's say, a week to do it. After that week's ended, you probably want to put your feet up and have a bit of a relax, don't you? You don't want to get into the office and start ploughing through loads of paperwork.
I think it's a great option if you're if you're a company that's really moved into the renewable sector and you're fitting lots of heat pumps, you're probably doing this yourself, aren't you?
Yeah, you're all doing in-house.
But if you're a company that gets an inquiry every now and again, you might do 2 a year, and you don't want to gear yourself up as a MCS registered, working under an umbrella allows you access to that marketplace without all the extra add-ons that you would have to get if you were MCS registered yourself.
Yeah, I think, engineers are getting asked questions about heat pumps from customers, and if you don't know where to go, if I turn around and go, I don't really work on heat pumps, that customer's gone now, isn't it? They're using someone else.
And it's not just, you haven't just given away that heat pump work, have you?
Yeah,
exactly. They're going to go back for any other work that they want.
100%. Yeah. So now, obviously, if you do get any inquiries about heat pumps, we can kind of get involved and kind of go through that process with you as well.
So fully support you along that full journey.
Yeah.
Is it worth registering now? If I was an installer, is it worth registering with that MCS umbrella now?
Do you know, I'd probably, if I was an installer getting asked questions about heat pumps from customers, I would probably attend one of the Baxi heat pump product days first of all, because we do, I like to think that we give an honest kind of view on air source heat pumps, and just see if that slots in with your business. I wouldn't watch this and then sign straight up to the MCS.
So, but what you're saying, I think what all of this is saying really, it's a bit like Andy's saying about heating systems getting heat pump ready. If you've got a gas boiler, get yourself heat pump ready. Get yourself more knowledge. Get yourself so that you understand heat pumps, so you can answer questions. That you're in a position that if a customer of yours does want a heat pump, somebody inquires about a heat pump, you will be able to give them the right information and, where relevant, say yes and install that, even if it is under like the Baxi umbrella scheme. Yeah,
and then at the beginning we talked about online learning and stuff like that. Everyone learns at different paces, don't they? Some people, they're brilliant in the classroom, and we go through some theory stuff on like low temperature heating courses, and it just clicks. Whereas other people like myself, I need to read things over and over again. So having that kind of online learning support available to you at all times, it's always there, because if you don't use it, you lose it pretty quickly, don't you? Well, that's what I find. It takes a while for me to kind of lock it in. But if it's always there for me, then I've got something to refer to. I mean, I still use notes from things that I made 5-6 years ago.
It's relevant.
Absolutely, the time as well. If you're doing some online learning, you can afford to do it for an hour, two, in an evening, rather than coming into sometimes a full day's classroom. Is sometimes difficult for some engineers.
Yeah,
and this is something we've considered in training, because we do partial online. With maybe a second day in the classroom, so we can mix that up and appeal to all audiences.
Yeah, 100%.
I think it's important that all training environments cater for all different types of learning, and some people absolutely want to go away study, and other people absolutely just want to sit in a classroom and take hands on, and that's for them. The vast majority of our installers, they like the hands-on experience. They like to be able to, that's where they really do their learning, and we see that in all the classrooms. But I think the overarching message really is, get information now. If you know a little bit, get some more. If you know nothing, start that journey on to understanding what the future of your industry will look like, and start grasping some of those opportunities. And we're gonna sort of wrap this section up really with a bit of a Q&A. So we're going to go over to Will. No pressure on Will there. What's the general inquiries you get through the technical helpline?
It always depends on what stage of the install they're at. So with an air source heat pump, for example. But a big inquiry we get is to do with the wiring of an air source heat pump. So which wires go where, basically.
Okay, and is it fair to say that wiring a heat pump is more complex than a
yes, it definitely
system?
Yeah, most boilers we've got a live looter and earth in the controls, haven't we? Whereas now, with my heat pump, we've got a lot more to connect up to it, haven't we? We've got zone valves, we've got external pumps, whatever it might be. So obviously the pre-plumb cylinder comes into its own there. Everything pretty much done for you.
Yeah, and it's. I think that's where the industry is at the moment. That there are technical challenges for installers that are being met by manufacturers like you say about the pre-plumb. So taking away most of that wiring, letting you concentrate on the areas that you're confident in. The plumbing and the systems. Slightly different way of thinking about how you design a heat system. But any other stuff you regularly get, Will?
Just while you're thinking on that, Will, just, it's an installer's concern about an S-plan heating system and the amount of wiring that brings, and the pre-plumb cylinder that we've had out since earlier this year does simplify that. It's all contained, pre-wired and pre-plumbed. So for some installers who are so concerned about having to then undertake S-plan heating system wiring again, they can have that option, can't they?
Yeah, it's a great solution. It really is.
I think we get people coming in and they want to understand the controller a bit more. When you look at the pre-plumb cylinder, if you're used to fitting the Baxi Combi or System 2 range, you'll find a lot of similarities there, which makes life a lot easier. When we look at the Baxi HP40 controller, it might be a little bit new to some people. So when they come in and understand the controller, because that controller will tell you an absolute wealth of information, compressor run hours, kind of run speeds and all sorts of weird and wonderful stuff on there.
So I think it's fair to say that it is more complex to wire a system on a heat pump. However, there are solutions out there that make it much simpler. So, Will, what's the number one question you get asked about heat pumps?
Difficult to pick a number one. There's so many inquiries we get about them. But if I had to, I'd probably say wiring. So what are the wiring requirements I have to fit on this heat pump? Obviously, it's a lot more complicated than a boiler. Just more things to put on there.
Yeah. So we kind of took that feedback on board from installers that said, they find it a bit tricky when it comes to the wiring. So that's why we kind of brought out the pre-plumbed and pre-wired air source heat pumps.
The trickiness there, Rob, seems to surround S-plan wiring systems, doesn't it?
Yeah.
Which we all know that can, are logical and we can fathom them out and follow sequences. But the pre-plumb cylinder takes away that requirement for an S-plan heating system, doesn't it?
Yeah.
So,
yeah. It is a step away from what we're used to, though, isn't it, in the heating?
If you've been fitting combi boilers for 20 odd years, then you'll be used to bringing a live, neutral and earth and some switch wires in.
Yeah.
Obviously, with an air source heat pump, there's a few more things you need to consider on that.
Yeah, and in fact, you talked about feedback earlier, and that's why we've introduced a new course, which is specifically for heat pumps, half-day wiring. We do have S-plan and Y-plan wiring day as normal as we've always done, but we've got a half-day wiring course aimed at the people who are actually wiring these things up, because one of the things we were seeing was people coming in, they were learning about heat pumps, they were going away, they're all happy, brilliant, they were fitting heat pumps, but they weren't the people wiring them, right? So then they'd have the electrician in who hadn't seen the inside of our training centre. And so we're having a half-day wiring day specifically aimed at the people who are wiring up heat pumps. So we give them all the inside knowledge. They'll be able to look at the pre-plumb cylinder, they'll be able to look at the standalone controller, they'll be able to wire it up, they'll be able to take that knowledge away and apply that on site. It is something that we're really concentrating on within training. And that whole piece about actually there's a bit of an unknown there, or a bit more complexity within a heat pump installation. What you're seeing is manufacturers designing in solutions for that. So making it easier, making it more compatible with what a traditional heating engineer would see. So yes, it's more complex, but there are solutions out there that are going to make it easier for you.
We're offering the 3-day air source heat pump qualification course in system design. We're offering the low temperature hot water and heating systems courses, water regulations, and of course unvented hot water storage systems. Yeah,
that low temperature heating course is really interesting because that applies to any heating system that you're designing, any heating system.
Absolutely.
Whether that is a boiler or whether that is a heat pump. But that's not all we offer here at Baxi. We've got a range of our own in-house courses. So Rob, do you want to just go through those?
Yeah, of course, yeah. So one of the first things you could get involved with is the Baxi Air Source Heat Pump Product Day, which is a bit of a taster session really to get you familiar with air source heat pumps. After that, you can do the BHPI, which is the Baxi Heat Pump Installer course. And that's like a blended learning approach. So there's some elements of online learning, and there's also a face-to-face session where you come into a training centre near you and go through installation and commissioning requirements. Will touched on it earlier about wiring. We go through all the wiring detail with you guys face-to-face.
And is there anything else, Rob, for somebody who really wants to get really involved in heat pumps and really understand everything about heat pumps?
Yeah, 100%. Yeah. So we also offer the Baxi Heat Pump Installer Masterclass, which is online learning. So there's 9 modules, and that will level up your heat pump game if that's what you're interested in.
Yeah, and that course is really designed for people who give a real depth of understanding, and also incorporates an element of face-to-face learning after you completed the modules, where you'll be able to put in practice some of the skills you've learned online.
Well, you're not kind of stuck to a time frame. Like I said earlier, people learn at different paces, so you can learn at your own pace and really take that information in as well.
And that's a real in-depth course, isn't it? So you're talking 9 modules. You're talking a good probably 8 to 11 hours to complete that.
Yeah, I'd say so. Make sure you've got a scientific calculator as well.
Yeah, but you will come away with some real great knowledge. And it's really important to understand that the Baxi training, what we're trying to do is we'll develop, competence, but also confidence, allowing you to take those skills out into the real world and use them in the real world. And that confidence will display to your customers. So when you're talking to them, you'll be more confident. You'll give them the right information. It's all part of Baxi trying to help you through that energy transition.
Yeah, I mean, we can't unfortunately give you the answers to everything, but hopefully you'll be able to leave the training centre with the confidence to tackle some of the questions that you get.
So one of the questions we do get on the technical helpline is around MCS registration. So does the installer need to be MCS registered to fit this heat pump?
Well, the short answer is no, they don't need to be. But if they want to claim the government grant money under the bus scheme, then the answer is yes. But there are 2 parts to this. So you have, if you want to do that yourself, if you're going full into renewables and you're going to make that a large part of your business, it's very likely that you will become MCS registered in your own right. And that will give you access to the grants. It will indemnify the designs. And if you design to MCS standards, then you will gain access to that money for your customer, which is great. However, if you're a one-man band or a smaller company and you're only getting inquiries into heat pumps, then an MCS umbrella scheme might be the right option for you. An MCS umbrella scheme, what that'll do is effectively take the paperwork away. It means that you can concentrate on the things you're good at, the installation part, interaction with the customers, all that remains the same. But and if you look at Baxi's MCS umbrella scheme, what we would do is we would send an engineer to do the initial design. So they'd go around and do the heat loss calculation. Then our back office team would design the system for you. Then you would go out and install that system as per that design. That's really important that you do it as per the design. And then once that happened, you'll get an assisted commission. And so the engineer would come out with you and commission the system, make sure everything's okay, check it all. Once it's all okay, the paperwork, again, done by Baxi, all the paperwork would be done in the back office, and that would give access to the grant funding. So we'd be taking all the pain points away from the one-man bands, the people only getting a few inquiries a year, giving you access to that marketplace without all the extra actions you'd have to take to become MCS registered yourself. So it's a great position to start your energy transition journey. That brings us to the end of today's conversation. Hopefully you've enjoyed our little chat and gained some information about the energy transition, about your place within that and how you can gain those opportunities. I would like to thank our guests today.
I've been Rob.
I've been Will.
And I've been Andy.
I've been Ian Trott. Hopefully we'll see you again next time on Baxi HeatWave.